am Mathilde Allègre. I'm a sustainability manager for LUBRIZOL Life Science. And I'm very sorry I don't speak Spanish, so I hope it will be okay. Otherwise, our partner, QUIMIDROGA, is there to help if you have any question after, and to answer in Spanish. So I'm going to talk about a well-known product line called Carbopol, and also some additional polymers from our innovation. So first, an introduction on these polymers. Then we will deep dive a little bit on the process and how we have optimized it for eco-design. We also give you an update on the status versus the microparticle, previously called microplastic regulation. And then I will end with some examples of more recent naturally derived and biodegradable polymers. So we have been pioneers in this technology of Carbopol, which are polyacrylic polymers, so cross-linked polyacrylic acid polymers and rheology modifiers. Those have been there for more than 60 years. And they were creating really a game-changing ingredient technology in the cosmetic and home care arena. And they are still very differentiating and still used a lot in innovation platforms today. So as I said, it's based on acrylic chemistry. So those are cross-linked. So you have the acrylic monomer here. It is polymerized and then cross-linked. So those polymers have a high molecular weight, which gives them, when they swell in the presence of water, that gives them all their rheological properties, stabilization and flow properties and thickening properties. And you see here we have two types of inky names, the carbomer, the homopolymer of acrylic acid, and another type of inky, acrylate C1030 alkyl acrylate cross polymer. Here you have an acrylate chain, which provides to the polymer some more compatibility with surfactants. And some of these polymers have a higher even acrylate range and have a trade name called PEMULEN, which we call them a different name because they are primary polymeric emulsifiers. So in this presentation, when I talk about Carbopol polymer, I will talk more about the powders. We have also Carbopol Aqua range with a different technology, different properties, which I will not address too much here. So in general, the main features of those polymers is that they are very efficient. You use, like in general, 0.5% in a formulation. So it means that you can have a lot of room to move to add a lot of further ingredients and still have a very high naturality content of your formulation while having the efficiency at low use level with a synthetic polymer. So they are very stable to temperature, to micro, so very different from products from gums or plants. They bring an excellent clarity. It's one of the main features of Carbopol is that you can get very clear and brilliant gels. And also another very important feature is their rheology profile. They are shear thinning properties. It means that when you apply a stress, so here, for example, in a pump or in a tube, upon stress, the rheology, the viscosity decreases, and then if you release the stress, it goes back. So it helps you, it allows you to make, for example, sprayable gels, which is very unique of Carbopol technology. And also, they give you a wide range of sensory depending on the grade you use. So you can have a very quick break effect, so very light sensory where the gel breaks on the skin. And depending on the grades, you can have more cushiony, more rich feel. And you can use those polymers to stabilize emulsions, and as I said, also for primary emulsification. So they can be used in a variety of applications. They are most widely used and known in beauty, but they are also used in health for example, topical gels, or for control release oral applications. They are also used in home and institutional, for example, in de-icing fluids for the airplane industry, for batteries and for laundry gels. They can be used to suspend pigments in coatings, and a very specific application also in the petrochemical industry. So as I said, I will now focus more on the process. So if you see on the right-hand side how we make a Carbopol powder polymer, so we use monomers in the raw materials, eventually some processing airs. It's a radical polymerization in a solvent, so it means that the product precipitates as it polymerized, and the solvent is then evaporated and recycled. So we have a process that is very highly controlled, allowing to have very low variability, and a lot of consistency in batch to batch. So this brings very high quality product for our customers. So we have optimized the process during the years. As I told you, we have been developing this technology, and it's there for more than 60 years. So we really work to get something with a low impact on the environment. So on the water aspects, for example, we work to reduce process cycle times and the frequency of reactor cleaning to use less water. The quality I already explained, so consistency, purity of the product. The energy saving, so this is a product that is made at ambient pressure, so no high pressure. And we have also developed lately grades of Carbopol at low temperature to reduce energy. And reducing cycle time, of course, reduce energy. And I will show you in a couple of slides also projects we have achieved at our main Carbopol plant in Belgium to change the origin of the steam used to heat the solvent to zero carbon steam. So related to waste, there is no byproducts in the manufacturing of Carbopol. So you have, of course, the solvent recycled, and no purification is needed. And then we have several plants around the world, which allows to reduce transport and, of course, CO2 emissions. So here, as you can imagine, we have assessed our process against the 12 principles of green chemistry, which is really something now that is very of high interest to our customers when you have a chemical process to make sure that it has been optimized on all those principles. So we address 10 of them, and the one we don't address, so renewable feedstock, biodegradation, is inherent to the chemistry because it's synthetic. And we have, of course, developed other grades, other things that are more biodegradable. And even on the Carbopol technology, in the Aqua platform, we have worked in including monomers from starch for biodegradability and maintaining performance. So as I mentioned, we have worked on the process for our plant in Belgium. So what are the main drivers for the product carbon footprint? You know, customers ask about product carbon footprints. They need to understand the impact of the product they buy on their Scope 3 emissions. So for Carbopol, it's very simple. It's the acrylic acid, the raw material, which is a key driver. And then it's the steam, because you need quite some energy to evaporate the solvent and then to recycle. So we have this, and then what we can say is that the footprint of Carbopol from Belgium, from Europe, is already quite optimized and low, because first we have primary data from our suppliers and of acrylic acid and steam. So what it means that we have their true data from their process, which are lower and higher quality than the data you get when you don't have this access to this information. When you do your footprint measurement, you use database information, which is industry average and is, of course, higher. So we have high quality data, but we have this big aspect of the steam, so where we work to optimize it. And so what happened is that last year we changed the source of the steam from from a natural gas gas fired boiler. So in fact, it's a boiler that is powered by natural gas. So natural gas have quite a high carbon footprint. And we change the source of the heat from residual heat from waste incinerators. So some heat that has been already accounted, and that is then zero footprint when we use it. And this has allowed to save, on an annual basis, 7,000 metric tons of CO2 on the plant, and on the product footprint, 20% lower footprint. So, why I am going to talk about regulations. First, microparticle, microplastic, probably you all are more or less aware of that. It's a regulation that went into force 3 years ago to ban the use of microparticles, which are solid synthetic polymers with a defined shape. You can find those microplastics in the environment, especially in the ocean, and they are very harmful to the live animals and to the environment in general. And why I'm talking about this today is because those Carbopol polymers in powder, when we deliver those in a box, you know, they are powders, they are synthetic polymers, they have the shape below 5 millimeters, which is a threshold limit. So when we sell it, it is in the box, it is a microparticle. It answers the microparticle definition. So you would maybe ask, so why is the industry still using it for a long time and still using it since 3 years the regulation has entered into force? It's because they are allowed to use it due to those two big aspects. So the first one is that when we sell microparticles, I mean the Carbopol, we sell it to industrial site. We don't sell it to our customers. So it's not where we don't know where it's coming and we don't know what's happening to the microparticles. It's in a controlled environment, an industrial site, and it is then transformed into formulations by our customers. So the fact it's in an industrial site, it is under the derogation 4A of the regulation, which allows their use, okay? So they are allowed to be used under this derogation. And secondly, when they are formulated into products, cosmetic or home care or whatsoever, you need to have water or, I would say, a polar solvent to develop the properties, the suspension, the rheology properties of Carbopol. So they have in their formulation this kind of solvent, and they transform the solid particle in a gel, which has not anymore a distinct shape and don't fall into the regulation anymore. So what happens is that our customers, when they make their formulations, they don't have microparticle anymore in their formulation. So one question we have is, how can I prove to the authorities if they come to me and ask, what is your... If the authorities come and tell you, how can you prove that you have transformed microparticles? So there is no specific demonstration methodology available because it would be very difficult. It depends on the type of microparticle and it depends on the formulation. But you can demonstrate with sufficient rationale and evidence that the SPM, so the synthetic polymer microparticle, is permanently modified, and there are some evidence that LUBRIZOL, as a supplier, we provide to our customers to support this demonstration. So first, we have microscopic information showing how the polymer swells. We can show by visual demonstration that you form the gels, which are very high volume. It swells like 1,000 times their original volumes. So we can demonstrate the physical swelling, and we can also demonstrate the irreversible swelling. It means if you remove the water from your gel, it does not go back to a microparticle state. So it's something that is also very important, is to show that it's irreversible, permanent. And we have also a white paper where we have gathered all the technical knowledge from our experts and from the industry on mechanism of swelling, etc., and experimental examples we have conducted, and literature references to help customers. So one thing that, just to draw your attention, because we provide microparticle in the box when we sell it, we have to label on our SDS, on section 5, the presence of this ingredient and how you should do to dispose of it, or how you should manage if there is any spills outside of the environment, to make sure you handle it correctly. So we have this kind of obligation since last year, and I put here for an aqua polymer, which is not a microparticle. On the SDS, we label that it's not a microparticle. And there is also reporting requirements, so for both us manufacturers and the suppliers. And here, you have to report a very general way on the REACH website, the REACH portal, sorry, the information on the ingredient. And also, eventually, if you release it accidentally in the environment, you have to report on the volume. So for us, it started this year. For the customers, it's starting next year. So now I will end up with a little insight on what else we have in our portfolio. Of course, to address the need for more sustainable solutions, we have been working to develop more sustainable, more biodegradable, and naturally offerings. So I won't comment on all that, but it's to give you an example of all the different things we can have. It's not exhaustive. It can be from natural feedstock, it can be from biotechnology, and the idea is really to allow our customers to put naturally derived claims on their packaging and to have biodegradability to manage the end of use of the formulations, which is extremely important, and to bring circularity to the product. So I will just show you, oops, it's dangerous. I will just show you a few examples. Here it's through biotechnology, so very low impact on the environment. And it's a gum, dietary gum, you may have never heard about it, because it's for industrial applications. And we leverage this ingredient into cosmetic. We found very interesting application for skincare. So you have both the application as a rheology modifier and, you know, the sustainability aspects. Your engine is a microorganism here. So it's very interesting. And then we have also another example where we took a very well-known ingredient, the xanthan gum, which is used widely in many applications, and we made a proprietary modification, but still having a very high naturality and high biodegradability. But we made this modification to have unique performance in sensory and in emulsification for skincare. And here, it's a combination of a cellulose from fermentation, guar, so guar is coming from it's a plant which was cationized, modified to increase compatibility with cationic systems. And then you have a very good performance in hair care and compatibility with cationic systems, so for conditioning of the hair while having all the sustainability credentials. And lately, the last example is also quite interesting because it's an oil thickener. It's not thickening water-based systems, but oil systems, which are difficult to thicken, and it's always difficult to get clarity and good rheology, good sensory for oil thickening. And here we have, it's a combination with a synthetic polymer. So you have some synthetic part, but still it has a high part from natural origin, from coconut, which is a better alternative to palm due to the deforestation issues linked to palm in the industry. So, to conclude, I would say yes, we have this knowledge in Carbopol technology, and those polymers are still today the best, I would say, the most efficient and the best cost-optimized rheology modification for customers. So they continue to use it. they can use it. We can support also regulatory questions for using the product. But we also, to address the market needs for both high performance and sustainability, we also develop more biodegradable and sustainable solutions from both internal innovation, but also open innovation to capture more expertise and address broadly the market needs. So that's... Yeah.